Hello everybody, welcome back to another Chem Complete lecture, and in today's Enolate chemistry series we are going to finish our Claisen material by taking a final look at the Diekmann Cyclization process. So this is also known as an intramolecular Claisen. So that's what we are going to take a look at today, and that's coming up on the channel right now. All right, so hopefully you've been following along with the series up until this point, because we did take a look at intramolecular aldol reactions, and we kind of set up some boundaries where we said if you want an intramolecular reaction to go with one of these condensations involving enolates, you need to have at least on the magnitude of 5 to 6 carbons that you're going to form in the intramolecular cyclization process that occurs here, because 3 and 4 membered rings are not stable enough. So if you didn't get a chance to see that intramolecular aldol one, I would suggest going back through and taking a look at that. You can just scroll back through the playlist. Okay, so today we are going to take a look at a similar process, but this will be for Claisen. And again, the name is the Diekmann Cyclization. So I'm going to need a minute to draw an appropriate length chain out here. So we'll go ahead and we'll say, let's use ETO. So again, remember that when we have ET, that represents ethyl. And so anytime you see something like ET or ME, methyl, ethyl, just know what we're working with there. Okay, so here's the ester portionality. Now I need to make sure that I have enough carbon, so we're going to go ahead and try to make a 6-membered chain here. So this, we'll call this the site of attack here. So I need 1, 2, 3, 4, 5, okay, and then 6 would be the enolate that's actually going to attack, right? And then I can put the ester on the other side here. Okay, so this is what we are looking at when we attempt to run something as a Diekmann cyclization or an intramolecular Claisen. So the same general process, we're going to generally avoid the use of hydroxide because of the potential for saponification, and so we will use the sodium salt of ethoxide in order to be the base, and then we could follow up using H3O+. Now the first step is going to be the formation of the enolate. We'll go ahead and make this one right here our enolate. And so give me a second to redraw this out here as the enolate, and then we'll go through the mechanism together. Okay, so there's my ester portionality. Now this carbon is going to act as the electrophile. The incoming enolate will attack that carbonyl right there. Okay, and make sure, as we spoke about in the aldol, the aldol intramolecular, it's also a good idea to count your carbons. So as you're doing this, you want to make sure you are counting your carbons as you go from the enolate that's made into the cyclic form. Okay, so here is our enolate. We'll give it the lone pair, the minus charge associated with it, and then here is the ester portionality on the other end. Now, this lone pair is going to come in and attack this carbonyl right here. So this will open up to its tetrahedral intermediate state. And from there, if you count, we're going to have 1, 2, 3, 4, 5, and then the carbonyl that opens up here will be 6. So I expect a 6-membered ring. I'm going to go ahead and draw that now. And again, you can kind of arbitrarily pick the spot that you want to be position 1 or 6. But once you do that, you go from there and you need to follow suit. So what I usually or typically will do is the site of attack, I will make that the top of whatever ring system I'm working with. So in other words, we're going to call this position 6 right up here. So if I look at what's happening at position 6, the carbon there would have the oxygen, and that oxygen would now be an O- from the way that the nucleophile enolate came in. And then I don't want to forget that I also still have the ethoxide group that's there as well. So that's going to be leaving in a minute as we wrap up the mechanism. But for now, I would still expect it to be present there. Okay, so from here to the right, I'm going to call that carbon 1, right? So if this is 6 and this is 1, then that would make this 2 and 3 and so on. So if I look over here at carbon 1 is going to extend into the chain. That's fine. We've already got the cyclic chain here. But it's also going to have the ester portionality over to the side. And so I don't want to forget that in this enolate that attacked here, I still have the O ethoxide ester portionality that's coming off of the edge there. Okay? So this would be the intermediate that I would expect here. I can then get this group to leave. And as it does, I would also expect a reformation of the pi bond right there. And this would lead to the final product that I would expect from this Diekmann reaction. And that would be the 6-membered ring. You would have the carbonyl that's returned here, and then you would have the ester portionality directly opposite. Right there. And that is it. That is exactly what I would expect. Now remember, the H3O plus, that second step that we have right here, is because once you have a alpha position and there's still a hydrogen that's hanging out here, right? When we made the enolate, this hydrogen right here has not gone anywhere. This is extremely acidic because it is now located between two potential carbonyls that could participate in resonance. And so you get a very acidic proton. You need something to kill off the remaining ethoxide or even the remaining enolate if it's trying to form, so that you can get your product here. And that is the product that I would expect, is this one right here. Okay. So that about covers the intramolecular Claisen, also known as the Diekmann Cyclization. So remember to go to chemcomplete.com. If you are looking for resources, you can sign up at the home page, and then you can get access to all sorts of free resources that we have over there. Helps to support the channel as well. There are guides available for sale if you would like, the thanks button to donate on YouTube, and as always, just taking the time to learn with Chem Complete and have me as your professor is the greatest support of all. So this is Professor Tomney. I am signing off, and I will see you guys in the next one.